Did you get a diamond for Valentine's Day? Well, if you did, is it the genuine article? Or could it be a much cheaper brown diamond that's been cleaned up using heat? Now scientists can tell you because this week UK researchers have unveiled a new super powerful scanning transmission electron microscope, or SuperSTEM for short, which can see individual atoms. And one of the first jobs it's been given, working with De Beers, is to look at the structure of diamonds. Danielle Blackwell reports.
Diamonds are a girl's best friend. Few can resist their shiny crystal charms. But not all diamonds are as alluring. Some are tinged brown, whilst others are blue or yellow, although they can be transformed into more valuable colourless forms with special heat treatment. Detecting when this has happened, though, has always been a challenge, meaning that keeping dodgy diamonds out of the market is difficult. Now, a new super powerful electron microscope, installed by the UK's Engineering and Physical Sciences Research Council, and which can pinpoint the position of single atoms, is enabling scientists to see inside diamonds to understand more about their makeup. From De Beers UK, David Fisher.
Well, if you had just carbon atoms in a perfect diamond structure, then you would have a colourless crystal. But what you can have is other atoms present within the diamond lattice. So things like nitrogen can incorporate into a diamond, and that's the most common impurity in diamond. Those defects will tend to impart a yellow colour. Boron is also a possibility, so if you have boron present, that will impart a blue colour. The other possibility is that you can get changes to the structure of the carbon lattice itself. Changes to that structure tend to be associated with brown colour.
Diamonds consist of carbon atoms arranged in a very ordered lattice structure, with each carbon atom linked to 4 others, like a collection of pyramids. But working out how the structure changes in coloured diamonds, or in diamonds that have been treated to remove their colour, hasn't been possible, as scientists lacked a microscope powerful enough to see individual atoms inside the crystal, meaning they could only speculate about what was going on.
Well, we knew from observation that natural diamonds that have a brown colour tend to have been deformed during their time within the Earth's mantle. One obvious possibility is changes in the lattice structure called dislocations, where the lattice has moved with respect to itself. So we first went looking for those using electron microscopy. It turned out, comparing the images and the concentration of those defects with theoretical calculations, that there weren't enough of them to account for the brown colour that we were seeing. And that's why we started to look at the possibility of the generation of voids. And these voids are extremely small. We're talking about structures about 4 atomic spacings in size.
These voids can be thought of as very small holes in the lattice structure of the diamond, which with the help of the new super powerful microscope, scientists can now see for the first time.
And they can take on various shapes dependent upon how the atoms at the surface of those voids are actually arranged. And we think it's that arrangement of the atoms that's very important in generating the colour that we see.
In a perfect diamond, where all the carbon atoms are joined to other carbon atoms, light passes straight through, and the diamond looks clear. But if the diamond contains voids, some colours of light will be absorbed, making the diamond look brown, which is where the heat treatment comes in.
The main driving force behind the research that we've been supporting in this area has been around understanding the potential to change the colour of diamond via treatments. So if you take a diamond that contains these small voids and is brown in colour, you can treat it at very high temperatures in excess of 2000 degrees centigrade. But if you do this, then you can remove the voids and therefore remove the brown colour. Treated stones are a legitimate product in their own right, as long as the consumer that's purchasing the stone is aware. There's a very clear commercial incentive to carry out this sort of treatment, because I think for an equivalent stone, looking at an equivalent stone that's brown and one that's colourless, you're talking probably up to a factor of 10 difference in price. What you have to remember, though, is that for the colourless stones, the treated stone will only command about 40 to 50% of the price of a natural stone that's untreated.
Not only can this super powerful microscope unlock the structural secrets hiding deep within diamonds, but will help scientists analyse the way atoms interact in other materials, aiding in many scientific breakthroughs, including advances in healthcare, power generation, and even space exploration.
Danielle Blackwell reporting on the new super electron microscope at the Daresbury Laboratory in the UK. So for those looking for a diamond engagement ring, you might be able to get a cheap treated stone and save some cash. Just don't tell your fiancé.